So today's topic is going to be perfect cube polynomial. A perfect cube polynomial is the opposite of a binomial cube. So in this case, remember when we got a binomial cube, the answer was something like that. The first term cubed plus 3 times the first one squared multiplied by the second one plus 3 times the first one multiplied by the square of the second one plus the cube of the second term. Or it can be exactly the same, but the second and the last terms negative if the binomial has a positive and a negative one. So this topic is going to be simple. The only stuff we need to do is first we need to order the polynomial to see if it has the structure we need. If it has the structure we need, then we will write the binomial cube. So it's only looking if it has the structure we need and then writing the binomial cube. So let's see the first one. On the first one, it's correctly ordered. Then if it's correctly ordered, the first one and the last one must have an exact cubic root. So it's going to be a and 1. So the second one must be 3 times the first one squared multiplied by the second one. And the other one must be 3 times the first one multiplied by the second one squared. So it's correct. It has the specific structure we need of a perfect cube polynomial. Then my answer is going to be, in this case, a plus 1, because all of them are positive ones, cubed. And that will be the answer for this specific exercise. A plus 1, all of it cubed. So let's see, it's a very simple topic. We only need to have a specific structure, then change it to a binomial cube. So let's see another example. So let's see, in this second example, it's not correctly ordered. So the first thing we need to do is to order it. So I will order it's going to be 8a cubed. Then it's going to be minus 36 a squared b plus 54 ab squared minus 27 b cubed. Then we need to look if the first and the last term have a specific cubic root. The first one has it and it's going to be 2a. The second one has it also and it's going to be 3b. Then check out if the middle ones have the structure we need. So the second one, it's negative, must be 3 times the first one squared multiplied by the second one. The other one must be 3 times the first one multiplied by the second one squared minus the last one. So let's check out. It's going to be, this one it's 4a squared, that multiplies 3b, that multiplies 3. So it's going to be 3 times 3, it's 9, times 4, it's 36. So yes, let's check the second one, or the third one, I'm sorry, the third one. It's going to be 3 that multiplies 2a that multiplies 9b squared. So if we multiply 3 times 2, it's 6, times 9, it's 54. I have a and b squared, so yes, it applies. So it has the structure we need, so the answer, it's going to be 2a, in this case minus, because we have plus minus, 3b, all of it cubed. And that will be the answer for this specific exercise. So it's not difficult. We only need to check out if we have the perfect structure of a perfect cube polynomial and then doing the binomial squared. Let's see one other example. So let's see this third example. This one can be a little bit confusing. Why? Sometimes, or the most common order is to put first the letters and then the numbers. But if here we put the letters first and the numbers after, we will get something like this. A to the 6 plus 882 a to the 4 minus 756 a squared plus 216. So if we do it this way, we can check out that always we have the a cubed. We don't have a negative on the first one. So if we put it like this, we will have a negative on the first one, and then it won't have this specific structure. So in this case, I can left it like it is because it has a structure that the first term has a specific square root, cubic root, that it's going to be 6. The last one also has a cubic root that is going to be 7a squared. So let's see how to do it. The first one has a specific cubic root that it's 6. The last one has a specific cubic root that it's going to be 7a squared. Then the second term must be minus 3 times the first one squared multiplied by the second one. The third one must be 3 times the first one multiplied by the second one squared. So it's going to be 3 that multiplies 36 that multiplies 7a squared. And the other one is going to be 3 that multiplies 6 that multiplied 49a squared. So let's see our multiplications. The first one, it's going to be 21 times 36. So it's going to be 756, so it's okay. Let's check the second one. Well, the third term, the second middle term, the third term, it's going to be 49 times 18. So it's going to be 9 times 8, I'm sorry, it's 72. So it's going to be 2, 8, 8. So it's going to be 882. So it's okay. So it has a specific structure. We need to have a binomial cube. So our answer is going to be 6 minus 7a squared, all of it cubed. And that will be the answer. So remember, a perfect polynomial cube is not a difficult topic. We only need to check out if the structure we have is the one we need for a perfect cube polynomial. And if it is that structure, then transform it to a binomial cube. So that will be it for today's topic. It's an easy one. So you can do the activity that is called perfect cube polynomial.